Right, good afternoon, everyone. We're talking about retrofitting PV panels on metal roofs. And the basic assumption is that the panels will be parallel to the plane of the roof.
Okay, super. So, Dennis, do you want to just get us started? You were going to be speaking about the primary function of cladding. Go for it.
All right, so I think first and foremost, people need to understand that the primary function of metal cladding is to provide a waterproof envelope to the building, and that all roofing systems or cladding systems are tested to meet the criteria for an inaccessible roof. So it's important to note that. The other thing is that the cladding systems are not tested for point load uplift. And that becomes a bit of a problem, and we'll discuss that further along when we talk about the support system. But first and foremost, everyone must please understand that roof cladding is not a working deck or a working platform. And then the other thing, of course, is that cladding adjacent to fixed access points on roofs is particularly vulnerable to abuse and may need some special attention at the design stage to have a platform that people step onto, or of course have access walkways. There's two main categories of cladding. Pierce fix, which everyone will be familiar with, the corrugated iron, and the IBR, but they need to note that there's several derivations of IBR where the web, or the depth of the rib, I should say, varies between 38 millimeters and 26 millimeters. And then there's a profile known as Industrial 7, which is mainly aluminium, and there are steel equivalents of that known by various other names. And of course, then there's the odd bit of the old ISCOR profile called Delta rib, that's still knocking around. And then of course you come to your conceal fix profiles, where you have the trapezoidal clip-on type, and you have the standing seam like Novatec C, which is a bit of a hybrid. And of course, the other one would be your Ziplock and those sort of profiles.
Mm-hmm. Dennis, what are the main points to take into account when retrofitting PV panels onto a metal roof? Okay,
there's quite a checklist, 11 points that I think people should consider. First of all, what is the material that the roofing profile is rolled from? Is it coated steel, or is it a non-ferrous metal, like, for example, aluminium or stainless steel? Secondly, what is the condition of the surface of that roof, and what is its estimated age? If you don't know the age, it's important to have a fairly accurate estimate. Is it a metallic finished roof, or is it a painted roof? And when it comes to painted, was it factory painted, or was it painted on site subsequently to being installed because the roof had weathered to such an extent it needed some additional protection? If it's a pierce fix roof, then you need to consider the condition of the fasteners and washers, and particular reference to the gaskets, the ceiling gaskets under those fasteners. Otherwise, you're going to have problems with leaks. And with insulated buildings, it's not always that easy to pick up where those leaks are originating from. Are there any end laps in those sheets? And what is the state of the end lap? Are they sealed? If it's a concealed fix, are the side laps fully engaged? And is there any mechanical damage or repairs on that roof, particularly where the repair has been used, where they've used a pop and lop stick-on membrane, because that is going to present problems? And are there any indications of ponding, or are there a discharge from extractors? And if we look at the first slide.
Emmanuel, can you just enable screen sharing? Because I'm struggling to share my screen, which has got Dennis's images on it. Hello? Is there anybody out there?
Yes, I'm here. I heard what you just said. Let me just go here to permissions.
So while we're waiting for Emmanuel to enable screen sharing so that I can show you what Dennis is speaking about, we do have these sessions every week. We alternate between roofing and cladding topics and structural steel topics. For those of you who got here just by getting the Zoom link, but you haven't yet registered to receive notifications about these events, just pop me a message. We can add you onto the notifications list. I'll also just put a link in the chat during the course of the talk that you can go and register to get notifications of these sessions. Fantastic. Thanks for that, Emmanuel. There we go. Can everyone see my screen? All good? Shout if you can't in the chat.
Yes.
Dennis, take it away.
Right. Well, the photograph on the extreme left is a classic example of ponding, and what it literally does creates a pond which becomes extremely corrosive because the pollutants, particularly the particulate pollutants out of the atmosphere, and causes rapid corrosion. And that's very evident in the left-hand photograph. The right-hand photograph shows you once it dries out, there's this mud that's left there, but also, again, very aggressive from a corrosion point of view. And on the extreme right is an extractor above an eatery, which has a gutter on it. It's supposed to collect the gunge. Of course, because of lack of maintenance, it hasn't, and it's leaking out onto the roof, and that is a particularly corrosive agent as well. So if you've got those kind of scenarios on a roof where you're going to be putting PV panels, you need to make sure there's access. Well, there's no ponding, and if there is ponding, then that roof is a problem, and we'll discuss that later. But the other thing is those extractor fans, whatever you do, don't cover up the downstream of where that stuff is flowing in the pan, because it'll be underneath the PV panels and they won't be able to get access to clean. Then the next thing we need to consider is in-plane roof.
Sorry to interrupt you there. We've just got a question from Johannes Hannekom asking, on an existing roof, if you do not have additional capacity for dead load, in your opinion, could you assume that your inaccessible roof allowance or live load of 0.25 kPa could be occupied as PV panels?
All right, the answer is no. And the reason for that being is the panels themselves with their substructure weigh in the region of 15 to 20 kilograms per square meter. So, and when it comes to, if you're talking about the structure, you can probably take that as a UDL, but then it leaves you nothing in hand for stacking of materials, etc. So, no, I think is the straightforward answer to that. And from the cladding point of view, the cladding would certainly support the additional loads because the cladding is tested to 0.75 kPa for construction period, and then of course that reduces to 50 for normal service.
Super, thanks for that, Dennis.
Does it answer his question?
So if any of you have any questions, pop them in the chat. If you need further explanation, also just pop it in the chat or put your camera on so that you can ask your question in person. There you go, Dennis. Sorry for interrupting you. Carry on. Okay,
fine, not a problem. Then the next thing is you need to identify if there are any in-plane roof lights. And that's where the translucent sheet is the same profile as the cladding and is fitted into the cladding. It's not on a standalone frame, and often can be very difficult to identify, particularly if the roof has been post-installation painted. And it's quite common for them to paint over these plastic sheets, which of course are A, very dangerous. If anyone steps on them, they're likely to fall through the roof. And B, of course, you don't want something like that stuck underneath the PV panels once they're installed. Then the penultimate item to consider is condition of the flashings, and are there any flashings that will be covered by the PV panel array. For example, if you've got that extractor that we looked at in that image, and you can see the back flashing going from behind the extractor chimney all the way to the ridge. Now, if you're going to cover that as part of the PV panel installation, you need to make sure A, that it's in good condition, and B, properly fixed. And then the final one is the microclimate surrounding the roof. And that would be up to a kilometer radius. And is the building located close to a major road, an informal settlement, or any high levels of industrial pollution? Because that again will affect some of the decisions that have to be made regarding the surface that's going to be covered by the panels. And then of course, if that roof does turn out to be either a galvanized roof, a titanium zinc roof, or Rhine zinc is the brand name most commonly used in South Africa, or a weathered, site-painted, galvanized roof, you cannot install PV panels on that roof unless it is coated with a suitable overcoat paint. And that is for the simple reason that those roofs will be very susceptible to inert corrosion or drip stop corrosion, as it's known.
So, Dennis, can you just give us a little bit of more of an explanation of inert corrosion?
Okay, if we go to the next slide, and then I'll talk around the slide. So I'll be with you in a minute. Just need to flip my screen. Okay, if you have a look there, you can see at the corner, the upside of the one panel and the downstream of the bottom of a PV panel, where it literally drips onto the galvanized surface, you get a rust spot forming, and it forms fairly quickly. On very new galvanized material, that can form as quickly as in 6 months. And on weathered, it's anywhere between 18 months and 2 years that these rust spots appear. And of course, you get through the coating very, very quickly. And if you look to the one in the middle, that's runoff from the support bracket clip on a conceal fix profile, and you can see the reaction from the aluminium, pardon me, the bimetal corrosion from the aluminium. And then on the extreme right is an enlarged picture of that rust spot.
We had a question from Katlego, Dennis. Just if you could repeat the types of roofs that are not suitable for PV panel installation.
That would be any galvanized, titanium zinc or Rhine zinc, pure zinc type of coat or metal. That's a single homogeneous product, or weathered, site-painted, galvanized sheets. You cannot install the PV panels until those sheets have been overpainted with a very good coating, because bearing in mind that the life of the PV panels is normally 20 to 25 years. So whatever's underneath there has got to be able to protect that roof surface for that period, failing which you at some stage will have to lift the panels and recoat the roof.
I have a question for Dennis. Simon Norton, International Zinc Association, Chemical Investigation Services. If all the solar panels are galvanized, then there should be no problems with runoff from the galvanizing onto a galvanized roof. What is causing this runoff onto the galvanized roof? And the picture you've got with aluminium, the galvanic corrosion can only happen if there's an electrolyte if there's contact between two dissimilar materials and the electrolyte is present. The photograph in the center doesn't look as though that was what actually happened.
That in fact did actually happen. It was the condensate that was running off on the perimeter of the PV panel installation that was getting wet and caused that contact spot to corrode like that.
So,
and then secondly,
So what's actually happening here is that you've got corrosive material depositing on the PV panels, and that deposit is actually running onto the galvanized surface, as opposed to the reaction between the aluminium and the galvanizing. Because if that galvanized, I can't see the drawing, the photograph quite clearly, but if that piece of aluminium is where it is at the moment and is not lying down in contact with the galvanized sheet, then there couldn't have been there could not have been galvanic corrosion, because they would have had to be in contact electrically. The surface area ratios would have to be correct, and there would have had to be an electrolyte there. So there's clearly runoff of a different type onto the galvanized surface from some other pollutant that's falling on the roof.
No, I don't agree with you, I'm afraid. And getting back to the PV panels, inert, or you probably would understand it as drip stop corrosion. Yes, it's a problem because the glass surface of the PV panel does not react with the pollutants as the pollutants would normally react with a galvanized surface. So you've got this concentrate of pollutants ending up on the zinc and causing the corrosion.
Dennis, we've got
Okay,
a
but
comment
then-
from David Freem as well, saying that the solar chaps wash the panels. That's what you see.
No, it's not. Definitely not. In my experience with these roofs, this is purely runoff, either due to low rainfall. If you've got high rainfall, it washes the whole thing off into the gutter. But if you're getting drizzle, mist, or like we do here now in Gauteng during the winter, and you get a high condensate in the early morning, that concentrated pollution, where it drips onto the galvanized surface, causes the corrosion.
Super, thanks. Dennis?
Okay, now we need to look at when we're going to install PV panels on a metal roof, the period that those panels are expected to last, the life of those panels, and we previously said the 20 to 25 year period, and the undersurface, the cladding that is underneath it, is now very exposed to corrosion because it depends on the flow of water, upslope flow of water from the ridge. Is it sufficient to flush out what's been deposited in the form of particulate dust under the PV array into the gutter? Or is it creating a poultice? And we'll discuss the poultice a bit later on when we come to the types of corrosion that you're likely to experience there. And then the other thing is, now, if you look at SANS 10400B, they talk about if the parts are readily accessible, you have to have a 15-year design working life. But if they are not easily accessible, you need a 30-year design working life. And the warranties offered by the majority, in fact, all of the manufacturers of the coil that is used to form the cladding, varies between 15 to 25 years maximum. And that warranty, please note, is to perforation, not to the first signs of red rust, but to actual perforation of the material. So we've got this conundrum at the moment, because if you've got a roof that's 15 years old, you've probably at best got 10 years before that coating is going to be needing some attention. So again, in making the decision to install the PV panels on the roof, you have to address the life, expected life that's left of that coating that's underneath it. And that's an important fact to remember. Then the next thing that we need to look at is the loading from the PV installation. There's the three loading conditions. You've got your self-weight, you've got your imposed load, and you've got your wind loads, both in accordance with SANS 10160 parts 2 and 3 respectively. And if you look at 10160 part 2 table 5, H1 is during construction, the cladding is tested for 0.75 kPa and a 1 kilonewton point load distributed over an area of 100 millimeters squared. So the cladding can take the loading, but then as it's transferring back into the structure, you need to make some allowance, and that's answering the question we had earlier, is can you assume that the 0.25 that's in the code will automatically support the panels? It's up to debate, and I think the respective structural engineers' discretion as to what they interpret that clause as being. Bearing in mind that
I think that Emmanuel had some questions there, or he wanted to just raise some of the questions that were in the chat. Emmanuel?
Yes, I just wanted to raise an interesting question that came in. If alum zinc has a similar issues as does the unpainted zinc that you mentioned earlier.
No, it does not. There's no evidence yet around the world where PV panels have been installed on a roof with 55% aluminium zinc alloy coating of this type of corrosion.
And then we have another question from Sarah. Just, is there a way to have a substructure to make the panels span between trusses instead of being supported on the roof purlins?
Well, I think anything's possible in structural engineering if it just has a cost implication. And what are they wanting to achieve, if I may ask?
Sarah, did you want to elaborate on that? No, I think she's, the purlins are failing under the additional loading, she's saying.
Okay, if she's asking that question, then that becomes a problem for the structural engineer to either decide how they're going to A, stiffen the roof if it's possible, or B, how they would then have supplementary loading. And that's quite a problem, I would think. Depending on the span of the purlins and the frame centers. I mean, that would be a major engineering requirement.
Emmanuel, did you want to weigh in on that question there?
Yeah, that's not sure which profession Sarah is involved in, but typically that would be an excellent question for the structural engineer on the job, who should be able to come up with a way to reinforce the roof that includes, of course, the purlins, the trusses, and the whole system to be able to carry the PV panels. And there are many different options for how you can achieve that. Yeah.
Okay, great. I've just had a slight technical glitch with my screen. I'm not sure if any of you can still see me sharing. So I'm just going to go and sort that out in a sec. Dennis, do you want to just carry on where you were from, and I'll be back in a sec.
Okay, and then the aspect of wind loading needs to be considered, because the wind loading across the surface of the roof is not equal. And if you go to slide 3, there's a little diagram. And that's a schematic of a duo-pitched roof, and it shows you the critical areas for high wind load around the perimeter of the building, and in some cases, depending on roof slope, on the lee side of the ridge. And if you look at the little table on the right-hand side, you can see that the magnitude is considerable. And first of all, when it comes to cladding, the CPE, which is the external factor, for example, on a 5-degree roof, is between 1.5 and 2 times the magnitude of the 10 square meter. Now, the 10 square meter is what is used by structural engineers to design the purlins and the rafters and the rest of the supporting structure. But from the cladding's point of view, you have to be able to withstand the much higher wind loading. And the same would apply to the PV panels, because the 1 meter squared area is the criteria. And those panels are individual pieces, so the load applied to them, you would have to take that higher load, and you can factor it. And there's in the SANS 10160 part 2, that table 5H1 that I mentioned earlier, there is a formula that if you are between 3 and 15 square meters, I think it is, or 1 and 15 square meters, you can reduce the loading. But nonetheless, the loading that has the design loading, if you have panels in those critical areas, is substantial. And we would strongly recommend that PV panels are not installed within those critical zones around the perimeter of the building. And as you can see, there's a little formula. The width of that zone is either twice the height of the structure to ridge, or the downstream width of the building. So that area on a very large building can be quite extensive, and it could be 8 to 10 meters, particularly on a shopping center, in from the eaves or the gable end.
Dennis, are there any other design criteria that need to be considered?
Yes, there's quite a lot of factors that one has to take into account now that you've established, is the surface suitable, what you're going to do to the cladding surface before you start. And then the most important consideration is the attachment of the brackets to the cladding. And within that, if you're using galvanized aluminium zinc or their painted alternatives or options, you may not use stainless steel fasteners. But if you read their warranties and you read their literature, all the manufacturers of those coatings will tell you you cannot have use stainless steel fasteners to connect items onto the roof. Okay, and then the next aspect is, of course, that the brackets preferably should be attached to the ribs, not in the pan, because there's several reasons for that. And the most important one is if we go, we'll come up, and there's a slide coming up where I show some examples, and I'll discuss the reasons why we don't want it in the middle of the pan unless it's going through into the supporting structure underneath the cladding. The only occasion where we do recommend pan fixing is when you've got standing seam profiles. And then, of course, we recommend that you don't fix to the profile itself, you fix it to the supporting purlin underneath. And then another aspect to be considered is with your concealed fix, particularly if you've got extremely long sheets, those things are moving around quite a bit thermally, and you cannot attach the brackets within 100 to 150 millimeters of the center of the purlin where the attachment clip is, to accommodate the thermal movement of the cladding. And the other very important thing is that the attachment brackets must not be attached to the side laps in the cladding between respective cladding panels, because there's a differential thermal movement there, particularly if you've got one sheet underneath the PV array and you've got one sheet out in the sun next to it. They are going to be moving differentially, and you can't lock those up by putting these clamps on. The next aspect that has to be considered is the clearance between the panels and the pan of the cladding. And we would recommend a minimum of 100 millimeters for practical reasons. And that is to facilitate the free flow of air, because you want the quick drying of wet areas. You don't want the ponding scenario or a poultice scenario building up there. And it must be remembered that all surfaces, including painted surfaces, are vulnerable to damage from extended periods of exposure to moisture and damp. Your paints do not remain impervious to moisture. They become pervious, they soften, and then you get corrosion between your paint surface and the metallic surface underneath. The other thing too, of course, is that if you've got a substantial gap there, you have a certain degree of self-cleaning taking place. The wind will clean out mainly vegetative debris and small debris that accumulates between those two surfaces. And it also, of course, then provides you access for cleaning if you're going to have to wash down the roof, and that is a recommendation. And of course, the roof does need to be inspected on a regular basis, and we'll cover that later under maintenance. The other important thing is the interface between the bracket and cladding needs to be insulated, and it needs to be either an EPDM or at the very least an EVA material. But certainly no closed cell materials are acceptable. I have not seen any evidence that those materials will stand up to anything beyond 6-7 years before they start to disintegrate. And the big factor here again to consider is that the gaskets, if they've got carbon in them, and normally they do have carbon in them as a UV inhibitor, that must be electronegative. Otherwise, you're going to set up an electric cell between your surfaces, your galvanized, or sorry, not your galvanized, your metallic surface underneath or painted surface underneath, and the aluminium alloy of the anchor clip.
Just a reminder, if you've got any questions, feel free to put your video on and ask, or you can just pop them in the chat and we will get to them.
Okay, so now we've gone. Hold on, we interfaced. Yes. Okay, then of course we've discussed the differential movements of these thermal movements of the cladding at their side laps. But the other thing is, if you have very large banks of panels on a roof, they are in aluminium frames, they're on an aluminium subframe, and the cladding underneath that is now cooled because it's acting as a sun shield for the cladding, and that differential in thermal movement needs to be accommodated somewhere. You can't have those clips being dragged along the surface of the cladding because you're going to destroy the coating. And of course, the big thing that needs to be considered with these things is that there should be access walkways. As we mentioned earlier, the roof is designed for access for maintenance of the roof cladding only. And if you're going to have regularly unskilled people walking across a metallic roof, and there's rules for walking across a roof, it's not a deck, so you can't just go walking anywhere. We strongly recommend the use of access walkways for servicing the panels and cleaning of the panels. Okay.
We've got Richard van Heerde with his camera on. Richard, did you have a question? You want to just unmute yourself if you do? You're good. You don't have a question. You just wanted us to see your face.
No, I've got a question.
Okay.
How you doing?
Very well, thanks, Richard. Yourself?
Lekker. I see Mark's also in the room here, so the question is probably more aimed at him, but you can answer as well. You're talking about 100 mil clearance of the panels above the sheet, the sheet itself.
Yes.
For maintenance purposes and air drying.
Yeah.
Currently, we have issues with guarantees from coil suppliers in terms of regular maintenance and washing. Large areas of roofs. I've got roofs in Durban you drive past, and probably 80% of the ridge to eave is covered in PV panels. Where does that sit in terms of the warranties?
We'll come to that under warranties, Richard. It's a major problem.
Okay, cool.
And regularly overlooked, unfortunately.
Okay, I'll wait for that.
Thanks for that, Richard.
Right, now if we could go to slide 5, please, Denise. And these are images of what and what not to do with the cables from the installations. If you look at the one on the left, that was a very heavy cable just in the pan of the cladding, which is not on because you're going to have crevice corrosion in between the contact surfaces, and of course you're going to have a buildup of contaminants in that gap between the cable and the rib of the cladding. And what we would actually recommend is that if you look at the photograph on the extreme right, that shows you a typical photograph underneath a PV panel installation. Cables lying in pans, in contact, create corrosion pockets and also inhibit the flow of flushing from rainwater to clean that surface, and plus they become a dam for small debris particles. And therefore we would recommend that everything is either in cable trays or on a system similar to that middle photograph, where it's away above the pan of the cladding. And even on the rib it can present problems, but at the very least they must not be in the pans of the cladding. Another aspect to remember is that if there are any copper components, there must be no runoff from copper, brass, tin, stainless steel components, because again, you're going to set up a bimetal corrosive scenario. And then finally, another point is avoid penetrations through the cladding if you can. Rather run the cables up to where you've got a ridge flashing or over the side, but preferably do not try to make holes in the roof, with particular reference to the very long sheets of concealed fix, which move around thermally. So any hole or penetration through the cladding needs to be able to accommodate the thermal movement of that roof cladding relative to whatever that penetration is. And then, of course, the other thing is that the panels are properly earthed, because stray currents, again, will set up a rapid acceleration of corrosion of the panel, of the cladding material. And now if we go to slide 6.
Sorry, just a sec there, I'll share now.
Right, okay. Richard, I think this should partly answer your question. And it is the location of these panels relative to the ridge or the upslope terminal point, if you've got a sawtooth type structure, because you have to get sufficient rainfall falling on this area that is between the ridge and the PV panel installations that is going to act as a flushing mechanism to clean out the pans of the cladding underneath, particularly in inland areas in the winters I mentioned earlier. We have a very high particulate fallout from the atmosphere, particularly if you're close to an informal settlement or railway installation or a freeway, and that needs to be washed out or flushed out on a regular basis. So that's something else that needs to be considered when determining the size and the extent of the banks of PV panels, that you are actually going to get this natural flushing. Otherwise, you're going to have to introduce a very regular washing of the roof. Right, then if we go on to the roof work itself, the first thing that we need to discuss is walking on a metal profiled roof. If you're walking up or down the slope, please walk in the pans, not on the ribs. And if you've got a roof like something like corrugated iron, then please try and walk on 2 ribs rather than on a single rib to avoid buckling it. And if you have to walk across the roof, try and do so within 300 millimeters of the purlin line, because otherwise it's on a very large roof where the spanning capabilities of the profile have been stretched to the limit. It's inevitable that either you're going to induce a depression in the cladding, or worse still, you're going to get an indentation or a collapse of a rib that is going to need repair. And then the other thing when it comes to roof work is cutting on the roof. The use of friction saws is a total no-no for a number of reasons. And one of which is that the particles, if you're cutting steel, can be way above the temperature, way above 800 degrees C, and they can burn into the paint surface, or they get themselves locked onto the metallic surface. And Denise, if you go to the next slide, please. And that's the kind of particles that come from cutting on a roof, whether you're using a friction saw or whether you're using a metal cutting saw. And those particles, as you can see on the right, if they're left on the roof, will rust and stain it. And of course, if it's a metallic surface, because they're steel, they will start to attack the zinc coating. They will draw zinc from that coating. If they paint, you're going to get, and it's a light colored paint, you're going to get a horrible stain. And of course, if people traffic this and grind it into your surface, you're certainly not doing anything to your painted surface underneath. In fact, you're messing it up. You're cutting through it, literally scratching and gouging into that surface.
Dennis, we just had a question from Nikita. I think it was related to the previous topic we were discussing. What is the minimum recommendation of the clear gap at the ridge for flushing of water on the roof?
Sorry, what is the gap?
What is the minimum recommendation of the clear gap at the ridge for flushing of water on the roof?
That is dependent on the rainfall for the area and the slope length relative to what's covered to what's uncovered, because you need to get enough rainfall on that bit of surface to be able to flush out underneath those panels. So it's not a hard, fast rule. It's proportional to that dimension to what is covered. And of course, the roof slope obviously comes into the picture as well.
Great, thanks, Dennis.
Okay, so please, control swarf, it's really a deadly thing, and it can have a big impact on the warranty, because scratches from swarf that have been trodden into the surface or early corrosion would be excluded from any coil supplier's warranty. And the final thing, when it comes to working on a metal roof, please carry things, don't drag them across the roof. You're messing up the coating, and which can often be irreparable, but also you can cause indentation of the ribs. And again, that could be problematic. And if you have to replace a sheet that has been badly buckled and cracked where the ribs have cracked, on a roof where that sheet is 60 or 70 meters long, it's going to be an extremely expensive repair. And then if we go on to the next slide. If you do have to have something that is placed on the roof, like this, the one on the extreme left was a support for an air conditioning unit, you need to have something between, at the interface between the steel support system and the metallic surface underneath. This particular example was a white painted roof, and you can see the crevice corrosion that is occurring at that interface between the two. And then of course the other thing is, please, no timber in any form on the roof for any period of time. Yes, you can have some dunnage there if you're storing your PV panels prior to installation, but no long-term interface between timber and the metallic surface, because you can see there the result of timber that has got wet. And you must remember the preservatives in timber are particularly corrosive if they're in the salt form. And the little diagram at the bottom is showing you need to insulate between those two surfaces. You can use a butyl-based strip there. You could use a piece of EVA, or you could just put down a bed of silicone, as long as you don't create a crevice and that silicone extends for the full contact surface.
Dennis,
Sorry,
we've got
Denise?
a question in the chats. Man, do you want to just take that one and then I'll ask my question?
Yes, just two follow-ups that I saw. One is relating to the relationship between slope and the distance from the roof.
Is that me freezing or is it Emmanuel freezing?
Yeah.
I think Emmanuel's freezing. Okay, let me ask my
Can you hear me,
question and
Denise?
then we'll get back there. Just Dennis, in terms of maintenance, what are the things that people need to be aware of?
Well, first and foremost, it's a myth to think that you've got a metallic roof and you don't have to do any form of maintenance. If you've got pierce fixed profiles, you should be inspecting that roof at least once a year. And if you've got conceal fix, a similar period, and all roofs after a severe storm need to be checked, because your pierce fixed profiles may have come loose, something might have come adrift. Your conceal fix profiles, you may have had some side ribs pop, and of course there's always the risk of losing bits and pieces of flashing from a roof. So maintenance, yes, is very important. If you read the warranties, and coming to those now, most of the providers of the coil, if you haven't washed the roofs or kept the unwashed areas, as they refer to them, your warranty is null and void. So you can negate your warranty if that roof surface is not washed. And the recommendation, if it's a coastal area, or an area of high industrial pollution, every 3 months, the roof needs to be flushed down. Otherwise, every 6 months. And I think it's a strong recommendation that owners of buildings have a regime that these roof surface and the roof cladding installations are checked at least annually. Then on the subject of warranties that we mentioned, when it comes to cladding, there are 3 warranties that apply. First of all, you've got the warranty on the base material, from which the cladding is rolled. And it's very important that people read and understand what those warranties are actually covering, and in particular, the exclusions and exceptions. The second one is from the profile manufacturer, and that gives you the performance of cladding where it comes to its ability to carry load and, of course, wind uplift factors. And finally, you've got the workmanship guarantee from the roofing contractor or installer. And normally, those warranties exclude any trades following the installation of the roof. And this becomes a bit of a hotspot, because once the roof cladding is handed over and other trades have access onto that roof on a regular basis, who did what, who caused what, etc. And if they're not properly resolved at the contract stage, when the contract is formed as to the extent, the roofing contractor would be quite within their rights to say, well, we didn't cause it, it's obviously not our damage, it's following trades, not our problem.
Dennis, we've also got a question just from Solly. Is when working with PV panels in areas close to the coast, say 2 kilometers, can the fasteners, bolts, washers, nuts, screws be stainless steel? And what is a specification for such areas? Not such as if this has been addressed before or not. Thanks.
The comment made previously, you may not attach anything to a metallic metal roof, be it aluminium zinc coated or painted coated with stainless steel fasteners. If the roof is aluminium, go ahead, as long as it's grade 304 and not 316, you're welcome to do so.
Super.
Denise, sorry, could we just go back to slide 4?
Okay, just a second. I just want to get there. Just while I'm going back to slide 4, just I'm popping in the chat now the link. If you got to the session just by receiving a Zoom link and you haven't yet registered to receive updates, the link that is in the chat now, you can register there, and then we'll make sure that you receive all the updates of the coming sessions. Dennis, I just need to get through to your slide 4, 2, 3, 4. Would that be this one over here? Is this slide 4?
That's it. Yeah.
Yay!
Okay. Now I just need to clear something off my screen so that I can see the full images here.
Yeah.
Just bear with me a sec.
And then also for our participants, if you've got a topic that you'd like us to cover in one of these upcoming sessions, please do feel free to send an email through to me. It's Denise, DENISE, @saisc.co.za. I'll pop my email address in the chat. Otherwise, just also, you could send your technical questions to technical@SAISC, and then we'll look at covering them in sessions coming up.
All right, here I'm just showing some examples of the type of brackets, etc., that are used. And in the bottom left-hand corner, you've got the typical attachment bracket for a concealed fix, where it's a clamp-on scenario. But what is very important is that interface encapsulated in the yellow rectangle, that surface needs to have a gasket of some description. It can't just be metal to metal. Otherwise, you're going to have the risk of bimetal corrosion and crevice corrosion coupled. Then it comes to the question, when on pierce fix, what kind of attachment you use. And the one on the top left-hand corner is a definite no-no, because first of all, you've got, goodness knows what the material is that's being used there and whether it's going to be durable. But secondly, you're blocking the trough from a water carrying capacity. And the other thing to note is the mark around the bolt where it meets the bracket, that corrosion pocket has been established there. And when it comes to attaching brackets to the pierce fix profiles like IBR and corrugated, if you're going to be attaching to the rib, which is preferable, you're then fitting a fastener into an extremely thin piece of steel. A comma-5 roof, when they talk about comma-5, that's the total coated thickness. And the thickness of the core within that, under that coating, is anywhere between comma-3.5 and comma-4 thick, depending on the country of origin of the cladding material. Our codes here in South Africa for the rolling of coated coil, and Australia, and is that it's 0.02, 0.03 of a millimeter tolerance on the core. But if you look at some of the Asian specifications, that tolerance can be as much as 0.04. So if you've got a 0.05 and you've got an 0.04, you're really skinning things down. And now you're putting a bracket on top of a sheet where your fasteners have to cut a thread. And that's what I'm showing there in that little photograph. You need to then use what is known as a flashing screw, which has a special point, and I'll discuss the purpose of the point in a moment. But what is very critical is that that shaft of that fastener is tapered and not straight. And the reason is, if you look at the little diagram at the bottom, is the point and that taper create like a flange in the very thin sheet to give that fastener something to cut the threading to form a proper and effective anchor. So you need to then, in using that type of detail, make sure that the pull-out value of the fastener is going to meet the wind load criteria that's applied to the roof. And we would suggest that you use the type of attachment bracket shown on the right-hand side of that image, because there the fasteners are not in tension pulling out of it, they're in shear. So you've got a far more stable type of connection. And particularly, it's not a single bolt or fastener. There's 4 for that particular design for corrugated. If you look at the 2 details in the bottom right-hand corner, those are not recommended because they're blocking again the water carrying channel, and the one on the left is you've got a pure uplift, again a pull out. So unless you're anchoring into the supporting structure underneath, that bracket is not the greatest since sliced bread. And the one on the right is sort of similar kind of problem, where you're relying on the pull-out value of the fastener, not the shear value against the, and if that's into the very thin gauge metal, again, you need to check your wind loading.